Our speaker is Marco Balduzzi, PhD researcher in applied system security, which this certainly is. Going to be speaking on automated detection of HPP vulnerabilities in web applications. So without further ado, Marco.
Yeah, thanks, Chris.
You're welcome.
So everybody, so if you are here, I think you are really into web. So some of the things I daily work is web. So today we're talking about parameter pollution is a new kind of web vulnerability that actually we discover affecting a lot of internet sites. That's why we did a study and we designed a tool to automatically detect this vulnerability. So this is what we will see today. So we'll start talking about what is HPP parameter pollution, so the different flavor of attacks, ranging from client-side to server-side attacks. And then we go into how to detect this flow in a real web application. I will then describe the experiment we run and the result we had from our evaluation. So just two words about myself, if many of you don't know me. So my name is Marco Balduzzi. I'm also known as with the nickname of Mbite. And I work in system security since a long time. And now I'm running a PhD in South France, where I moved 4 years ago. So there we have a research center where we work on different topics of system security. For example, something like we have a team working on malware analysis, and our team that look up for new vulnerabilities. So I have some colleagues working, for example, on privacy of social networks, and of course web. Yeah, you can check out my homepage. There are a couple of information on different work we do, and we always welcome interested people in joining us for internship or even for PhD programs or for work. Yeah. Okay, so as most of you know, the web has really evolved in this last 10 and 5 and even 10 years. In the past, it was just barely a collection of simple and static pages. While now, web applications are fully customizable and they are pretty complex. So they often embed a multi-tier architecture and many complex systems now as a web interface. So this is the web, how it was before. So this is a screenshot of a Mosaic browser in, I think is maybe IRIX. This is the web now, okay? So do you see that, there was a big change in these last years, and the consequence of that is that web security has really increased of importance. So you can think at the top 10 project run by OWASP, or you can think that 60% of the attacks now, if we look at the SANS top cybersecurity risk, are actually targeting web application. Web applications are also targeted by bot master because often they try to hide the command and control server of botnets over a web site that has been compromised. If you look in that instead from the malware perspective, there are more and more malware that are targeting browser. So we have a lot of malware, for example, for Internet Explorer, and this malware they basically work as a keylogger or network logger. So they can steal, for example, your credit card number when you type into the browser. So a lot of work has been done in detecting different type of web vulnerability. In particular, if we look at the web injection vulnerability, such as SQL injection, cross-site script, and command injection, there are different tools that have been proposed by the research community and even by companies. So we have tools, for example, that work in a white box approach. So actually they analyze the code using static analysis techniques. There are instead other tools that use a black box technique, where they actually fuzz the application with some special input and then check whatever the application sanitize the input or not. So as you can see here, a lot of work has been done on detecting this classic injection vulnerability. The problem is that recently, pretty much in 2009, in OWASP, Poland, two Italian guys, colleague of mine, Stefano Di Paolo and Luca Carrettoni, they came out with a new class of injection vulnerability that is that they call it HPP parameter pollution, and this is still pretty much unknown to many of us, especially if you don't work in web. And so this is why we are here to talk about parameter pollution, because we would like to show that actually a lot of internet sites they are affected by this new class of web vulnerability. So basically, in 2 words, the attack consists of injecting query string delimiter, that is usually the AND, or the encoded version of AND, in existing HTTP parameter that are passed to the application using GET and POST. And the problem arises when the application does not correctly sanitize its input. So in this case, HPP can be used to launch different kind of attacks, ranging from client-side attack to server-side one, or even it's even possible sometimes to bypass standard web application firewall. So I will go in detail of this problem in my talk. So, what are our research objectives of this work? So the objective are actually 2. The first one was to create a system to actually assess web application in order to find out how many possible and real web applications are vulnerable to this problem. So we want to answer to these 4 types of questions. The first one is like, is the problem being exaggerated by the media? Is this problem known by web developer? Does this problem occur more in smaller sites or rather in larger and important sites? So finally, what is the significance of this problem? Okay, so this is about the introduction of the talk. And now we are going to dig into HPP parameter pollution. So I'm going to tell you what it is. We will see a couple of examples of the problem. And just feel free to ask questions if you don't understand how does it work. I'm here actually to explain you what is HPP parameter pollution, so feel free to ask. So we start with talking about HTTP parameter handling. So that is, when you interact with a web application, actually you provide information to the application, okay, using standard parameter that are in a GET, in a POST, or in a cookie, okay? And actually, HTTP allow the same parameter to be provided twice. This is, for example, a common use for form checkbox. So I don't know if, let's see if this link works. Yeah. You see here you have a form. You can say, I have a bike, okay? You submit, and actually what you submit a parameter called vehicle, and the value is bike, okay? What you can do, you can select both of them, okay? So in this case, you submit the same parameter, vehicle, 2 times, okay? So this is a normal standard behave OHTTP. And so there is nothing bad with this. What we can ask to ourselves is what happens when the same parameter is provided twice. Suppose you have an application that usually accepts a single parameter, and you provide twice the parameter. So let's look at Google. You see, in Google you can query for Italy, and then I can even query again for China. So actually I duplicate the Q parameter twice. What Google does, it actually concatenates both values, putting a space in between, okay? So you follow up in having a string Italy space China. If you do the same on Yahoo, exactly the same. Here the parameter is called P instead of Q, but it's basically the same. What Yahoo does is just consider the second parameter instead of a concatenation of the two. So from here, you can already see that there is not a standard behavior on how the two parameters are actually handled by the application. So what we did, we manually test 5 common methods, as you can see here in the table. So depending from the technology are you using, okay, and depending from the type of the server, you can have, for example, the first parameter being considered, for example, in the case of Tomcat, where it's red, or the second one, or actually you can have all of them considered. And what is interesting to see is, for example, in Python, if you submit the same parameter twice, you follow up to have a list. Okay, so this is this behave, as I'm saying, depends from the technology you are using and from the different method you are using server side to retrieve the parameter sent by the client. So there is nothing bad with this. If, so the big if is if the developer is aware of this behavior, okay? And so this is the problem. The problem is that, web developers were not aware of the fact that actually a client can submit the same parameter twice, or can be able to inject a second parameter and follow up in having in an unexpected situation. And this is usually what the security guys look for. So now we go into HPP parameter pollution. So I'm going to show you how this parameter handling affect actually the pollution, so can be used to run actually an attack. So the first things we will see is the client-side attack. So in the client-side attack, you have a site that is vulnerable to the parameter pollution. So the bad guy realized that this site can be used to perform attacks. So what it does, it creates a trigger URL. So you can think of a trigger URL like a URL that the attacker sent to their victim, and then when their victim click on this URL, actually they follow up in having a page that is somehow being modified by the attacker. So it's something similar to cross-site scripting, okay, where you send this trigger URL to somebody, and when somebody open this page, yes, this page being modified. For example, in the cross-site scripting, you have this page being injected with your JavaScript code. Here instead, what you inject is not JavaScript code, but is actually this extra parameter that the attacker want to inject. And what you can do with a client-side attack, you can, for example, force your victim to delete their personal emails. You can, for example, on a social network, you can automatically generate a friend request. So when the victim click on this link, you automatically generate, for example, a friend request to the attacker. Or you can, for example, have their wall of a social network being compromised with unintended content. Or even worse, you can maybe follow in a, let's think of an e-commerce site. You can maybe follow up in buying something different. So maybe you want to buy for a product. When you click on this product, actually, you follow up in buying something else. So now we see 3 examples of this class of attack. The first one is what I call unintended voting. So you imagine you have an application, an electronic application, an application that you use for electronic voting. So you have 2 candidates, okay? One is Mr. White, the other one is Miss Green, okay? And so this is the URL of the application, okay, that take a poll ID, and then this ID is used to look up the poll and build a page where you have the 2 links, okay? So finally, the user can vote by clicking the first link or by clicking the second link, so there is nothing strange with this. What you can see here is that this pool ID, okay, server side is actually taken and used directly to build the 2 links, Instead, in fact, the two links here, they contain the pool ID, okay, that specify, okay, for which pool you are voting. So in this example, if a pool ID has not been correctly sanitized, what the attacker can do, he can create this trigger URL, what you see here, where actually he append to this 4568, he append another parameter called candidate with this value, green, and he encode this new parameter using, in this example, the standard URL encoding form, the %FF. So the end become the %26 and the equal the %3D. So what the attacker does is send this trigger URL to their victim, okay, to people around. Then these guys, they click on the URL, they open the page, and the page is just show, the different candidate to vote. So there is, it's just the standard page, and if there is SSL enabled, there will be SSL enabled. So actually, we have not, the attacker will not, attack the application itself, but just he will modify the two links that are generated by the application. In this way, when the victim vote, the victim follow up in voting always for Miss Green. So even if I click on the first link or click on the second link, he always vote for Miss Green. So in this example, the attacker forced their victim to vote always for Miss Green. Why this happens? Because he was able to inject this new candidate equal green. Okay, and as you can see here, this candidate equal green get injected before actually the real candidate that would have been submitted to the application. And since the application is written in JSP, as we saw here in JSP, okay, when in JSP, when you have two parameters with the same name, the application reads just the first parameter, okay? So it's the opposite of this. Here, when you have two parameters with the same name, you get the second. JSP gets the first one. So if the attacker, this is the idea, if the attacker is able to inject a new parameter, and this new parameter follow up in being before actually the parameter submitted by the user, he is able to overwrite, okay, override the parameter submitted by the user. Now we can see a second example. This is about misleading shopping users. So I'm trying to zoom a bit for the people that are on the back there. I don't know if you see. So actually, yeah, it's a bit. So here you have a parameter called P that specifies the product ID that you are looking for on the internet site. So what is possible? It's possible to inject another P parameter, or actually the encoded version of this P parameter, but then is it follow up in having these links here, add to cart, compromise. So at the time when the user click on this item and for buying the product, the user follow up in buying another one. So instead of buying intervention season 1, you follow up in having crime something. So this is an example of how electronic e-commerce site can be actually manipulated to force victims of this e-commerce site to buy something different. So the attacker can actually spam around a lot of trigger URL that actually trigger this vulnerability, and they made the user buying their own product, the product of the attacker. In another example, the first example is about this sharing component. So now with this Web 2.0, everybody is using this nice retweet button or share on LinkedIn or share on Facebook button. These are often used in form or in blog post, where actually you click and your blog get shared on your profile, okay? So here we found a vulnerability in Facebook where actually it was possible to send again some trigger URL to the victims. And then when the victims visit this page, they have the page with a blog post. But then when they click on this share button, instead of having the blog post shared, they have shared on their profile something that the attacker decide. So in this way, the attacker can spread a kind of malware in the blog post, in the wall of the different users. So you can see it. You can see it here. If let me see. So here you have, for example, this. Quality is not great. So you can see here you have this blog post that is about this unknowns. It's about a blog post for selling this motorcycle. Okay, this Honda motorcycle. Here, what an attacker was able to do was to inject actually the URL in this example. It's this URL iseclab.org is the URL of our research lab. But suppose he can inject the URL of a drive-by download site. And then what's happened is that when the user then click on the face button to share this announce of this Honda motor PC, Honda scooter, actually what he follow up in having instead another internet site being shared on his profile. So in this way, the attacker can easily spread URL pointing to his malicious site that then can maybe contain drive-by download content. So in this way, when the user visits the site, they get his browser get automatically compromised. Okay, this is about client-side attack. So in the client-side attack, we saw that the attacker forced their victim to do something unintended, and that is useful for the attacker. So the attacker can be able to make the victim buy something different, or to modifying their Facebook wall post with malicious content. What is possible to do is also a server-side attack. So if a server-side attack, the attacker attack directly the application. Okay, so this is something that's more similar to command injection or SQL injection. So you can do actually different type of attacks depending of the application you are dealing with. So let's look at this. This is a payment system example of two friends of mine. They give me this example. So actually, suppose you have an application, okay, a front-end application that received a request, an HTTP request, okay, and in this request you have two parameters. One is the amount of money that you want to transfer, okay, and the other one is the recipient of your transfer. So what the front end does, he actually built a query for a backend server. Okay, actually it's a post. So the application, the front end makes a post to the backend, specifying that you want a transfer of this amount of money to this guy. Here, what an attacker can do, can create this trigger URL where actually he inject this new action that is a withdraw in the name of the recipient. What it happened on the front end is that then the query that is generated for the backend get injected with this new action, okay? Because what it does, this code, it's actually what it does is it retrieve the recipient name, okay, that is Matt. Okay, but in this case, you have Matt and this red code there that get decoded and follow up in the request that the front end does on the back end. So in this case, what an attacker is able to do here is able to override the action that is a transfer with the action that is withdraw. So possibly he can be able to retrieve money instead of transfer this money to somewhere else. What we can do, you can even do hijacking of the database. So suppose you have again a backend, a web application actually. Here it is. Okay. So suppose you have again a front end. We take a parameter called department. Okay. That is equal to engineer. Okay. What the application does, it builds a query for the database. Okay. And the query is something like select user from table where department equal engineer. So it's basically an application that is a web application that is used to look up users of a specific department. So suppose you have you are in your company, you want to look up your colleague that work in the department of engineering. So you can use this application. You specify, okay, I want department engineering, and the application give you the list of your colleague. Here, again, if you are able to inject into the department parameter something that is something like this, what equal password, what happens is that then the backend code will generate a query on the database where actually this select, it will contain not select user, but it will contain select user, comma, password. Why? Because the attacker has been able to inject a second parameter called what, and in this case the application is ASP, and in ASP, as I showed you before, when you have two parameters with the same names, the value of these two parameters get concatenated with a comma. So in this example, the attacker would have been able to get not only the list of users, of colleagues, this example, colleagues of a department, of engineering department, but he would also be able to have the list of password for these users. This is another example, and this is a real example that is being exploited by Nir about the blogger system of Google. So here what Nir was able to do was to get administrator privilege over any blogger account. Okay, this is pretty scaring, and the problem here lied in the fact that actually in Blogger you can invite somebody else to be an author for this blogger, and here the problem lies from the fact that the server-side code did not check for whatever this parameter called blog ID was submitted once or twice. So here it was possible to duplicate this parameter, and in this way to force the application to register, for example, me as author of his blogger, of another person. So I don't know if going into the detail, if it's of interest for you, but it was working like that. So you have, it was enough to send actually a post, okay, where you specify, so actually it's like that. You register, you open a blog, okay, so you register on Blogger, you open a blog for you, your personal blog, okay. Then you go into, you log in into your blog, okay, and then you do a post, okay. You do a post for a normal post that you have done when you want to add an author to the blogger. So here, what you do, you specify the attacker blog ID value, okay, that is actually the blog ID of your blogger that you just registered, and then you append another blog ID parameter where you specify the victim blog ID value. So here, Google, what he was doing, he was just checking the first value of blog ID. So it was saying, yes, you are actually owning this blogger. So you can add other people to the blog. But actually, he was executing the action on the second blog ID. So he was adding this person as author to the blog ID of a victim. So here it was enough. Here you have to see you have an email address, attacker email, in this author list parameter. So in this example, it was enough to add the email address of the attacker, and then the attacker would have received an email saying, hey, these users want to add you as author of this blogger. You just say okay, and you become author, and then you can do privilege escalation and become actually administrator of a blog. Okay, so we have seen a client-side attack, parameter pollution, and server-side one. Now we go into more use of parameter pollution. So we have 3 different uses for this attack. So the first one is cross-channel pollution. that means that you can not only override parameters that are in your same channel. So for me, channel is either a get, either a post, or either a cookie. Okay, so in the example we saw before, like something simple, like this one, you actually inject the parameter in a get. Okay, it's the first one is a get, and then you have your parameter injected in a get below. What you can do, you can inject in a get and have a parameter override a value in the post. Or even worse, you can inject parameter in a get and override a value in a cookie. If you check out the white paper, there are some examples of how it works, this technique, and it's pretty interesting. The second use then is to bypass cross-site request forgery tokens. So I don't know if you're aware of that, but a standard mechanism to protect web application against cross-site request forgery attacks is to use this random token, and that are actually generated by the application. Every time application generates a new token that is then sent to the client, and then the client send back the token to the application to just to prove that he actually is not running a cross-site request forgery attack. Here in this example, again, it was this example show that it's actually possible to bypass this mechanism using parameter pollution. And this is an example taken from the Yahoo attack, where it was possible to generate a trigger URL. But when you actually click on this URL, you have your Yahoo web application, okay, your Yahoo webmail open up. You log in into your webmail. Okay, so you log in and you can see, okay, how many new email you have and so on. So when you click on inbox to see your new email, you get automatically all your email deleted and and your trash can being cleaned. Okay. And in this example, Yahoo was actually using cross-site request forgery token. So this shows that it's actually possible to overwrite this token. And if you want, I can go in detail and show you, like, for example, how it works. So here you have a token that is called, you see random token? Yeah, it's this one, .rand. Okay, so do you see Yahoo actually is generating this token to prevent cross-site request forgery attack. And here, since you are actually injecting this new command, what you see, it's called, actually there are two commands. One is empty trash, okay, and the other one is delete on the right. And what's interesting to see here is that the first command on the right, it's encoded using a standard URL encoding, because the first things you want to do is actually to delete the inbox of your victim, okay? And then the second action you want to do here is to clean, to empty the trash. So the command fmgt.empty trash, as you see here, is encoding using the double URL encoding, that is %2526. This to show that in parameter pollution, if you use often if you use a single URL encoding, you're actually eating the first layer of a web application. Instead, if you use a double URL encoding, you can actually force a command to be executed after the first one. It's a kind of way when you want to run multiple attacks at the same time. It's a way to give a precedence to how this attacker carry out. So I know it's not easy to see this point. So the last one, it's what many people get interested of, and now we have a lot of web application firewall providers that are actually fixing this problem, is the fact that by exploiting the fact that ASP concatenate two parameters with the same value, it's possible to split a payload, okay, for a web application attack, for example, a SQL injection payload, okay, or a cross-site scripting payload, whatever you want. you can split this payload by multiplying by using the same by providing the same parameter multiple times. So here you see a parameter called ID that contains a SQL injection. Okay, this SQL injection most likely will be detected by your web application firewall. So now an attacker can repeat this ID multiple times, and then the consequence of this is that this payload will bypass the web application firewall, okay, because the parameters are being splitted. And then when the web application firewall has been passed, the full string will be concatenated again, and then you will take out the attack. There is also another, the second version, it's a bit more complex, but actually does the same. Good. So I hope you are not going to sleep. Conference is almost at the end, and we're all tired. So my talk is in the middle. So here you have okay, I show you what is HPP parameter pollution, and I give you a bit an idea what kind of client-side attack you can do, what kind of server-side attack you can do. And now we go into the detection. So the question is there a way to detect this problem in an automated way? Yes, there is a way. There are actually different ways. So what we did, we designed a tool that does black box testing. So that means that we have an application on the right. And what we do, we test the application without knowing the source code of the application. So how we do it? We do it using an instrumented browser. So in this case, we have a Firefox. Okay, what we did, we modify Firefox and using some browser extension. Why we did so? Because at the beginning, I had wrote a Python code for crawling the website and for sending requests to the website and getting answer back of it. But then if you do like that, you have to cope with all the applications that use client-side code for such as JavaScript, for example. So you need an interpreter for JavaScript. And now the web applications are very complex. So it's not easy to write a simple code that crawl the web application by yourself. Instead, if you use a Firefox browser, or let's see, in general, if you use a browser, you can say to the browser, hey, go to, I don't know, facebook.com, the browser automatically load the page, execute the script, load the different iframe, load the images and everything, and when the page is ready, the browser gives you automatically the page. Okay, so the browser does everything for you. The browser also extracts the information from the page by providing you the access to the DOM, so you have automatically all the link of the page being extracted, all the forms of the page being extracted, and everything. That's why we went for this solution. So we have this Firefox, this modified version of Firefox. Then we have the crawler. Okay, it is a component actually that crawls the internet. It's the web application you want to test. Okay, so you can configure the crawler and say, yes, just check the home page of the site, or check up to depth 3, so it follow up to 3 links. Then the crawler also submit forms, of course, and then this crawler talk to two other components that are actually the main component for detecting parameter pollution. One is called vscan. V stands for vulnerability. Okay, so it's the component for doing vulnerability scanning, so to see if actually there is a vulnerability on the page. And then there is another component called the pscan that is for checking for the precedence. So this one tells you whatever the precedence is on the first parameter or in the second parameter and so on. Okay, I'm going now into the detail of how it works, these two components. So we start from the pscan, that is one that actually analyzes the web, a single web page, okay, and tell you whatever this web page accepts the first parameter or the second or both of them. So you're asking to yourself why we need to do so. I will show you later that suppose you have an application that is actually vulnerable to parameter pollution, so you can inject a parameter, okay. The question is, yes, now that you have injected the parameter, can you actually override existing parameter or not? Because suppose you inject a parameter, but this parameter follow up in a position of your link that actually does not allow you to override the existing parameter because the precedence is wrong. So we have this component that tests for the precedence, and we can say whatever a vulnerability can bring to exploit the application or not. So what it does is, if you have a page, okay, like this one, where you accept just a single parameter called par1, what it does, it generates a new value for this parameter. So if, for example, if this is a number, generate another number, and make a request and get the answer. And then generate another request where you have two parameters with the same name but different values, and then easily just check the answer, and it's pretty straightforward, you can think. So if page 0 is equal to page 2, the precedent is on the first parameter, otherwise it's on the second. So this is a very naive approach. So actually in theory it should work. The problem is that a lot of modern web applications now are pretty complex, and they insert a lot of information that are dynamically generated. Just to make an example, suppose you go on a search engine and you search for Marco. Then you search again for Marco. The page you will get is not the same. So it seems the same, but for sure the page will contain something like, okay, today is, I don't know, now it's 5 p.m. And then if you do the request later, it will tell you, okay, today is 5 p.m. is 01. Or maybe it will tell you, okay, your search has been served in 1 second, and the second time, since the web server was busy, it would have tell you the search has been served in 1 second, comma 5. So the problem is that this naive technique does not work well because the applications are complex and they have a lot of dynamic content, such as, for example, advertisement. So even if you request the same page multiple times, if advertisement can change, this is random. So how can you compare the page? So what we did, we actually tried to remove all these dynamic components, like embedded content such as Flash, apples, iframe, style sheet, and so on. And then we used some mathematics heuristic, I don't go into detail, to actually check how much the pages are similar, okay, basically. Then in the paper you have more detail if you're interested to know how it works. So this is how about pscan and how we are able to see whether the precedence is on the first parameter or in the second. Then we have a second component that is that one for the vulnerability. So here what we do, we actually have a nonce, okay, that is a parameter foo with its value bar, that is called nonce because it's a parameter that is harmless. And the solution here is to test for HPP vulnerability. It's pretty easy. You just try for each parameter that the application accepts, either in a get or in a post, you try to inject this nonce. And then what you do, you check whatever in the page you get from the web application. You check whatever this parameter has been actually used to build links or forms. And so the basic, what somebody can do is to inject this parameter in all the this nonce in all the parameter accepted by the application. This works. But to be fast, what we did, we actually create 3 sets of parameters. So the first one are those ones that appear in the URL of the page and in the body, and these are pretty much the parameter that are used by the application under the same name. So it's like in this example. So yeah, like here you can see the pool ID value is actually read by the application and then used to build the link under the same name. This is not always the case. So sometimes the value of a parameter, yes, is used by the application, but then is then used in the generated page under a different name. So what we do, we also try to inject parameter in value in parameter that has a different name. Here again, I will skip the detail for this, otherwise it's getting a bit complex. But the idea is basically this one, to inject these nonce in the parameter accepted by the web application and check whatever you have it in the answer. So what we did, we implemented a tool, okay, that we call PAPAS, that is an acronym for Parameter Pollution Analysis System, and we use this tool actually is like this, as I will show you before. So we have Firefox, a modified version of Firefox for crawling the web application. Then we have a different component that talk with the browser using TCP sockets. This allow us to have multiple sessions of the browser in order to scan multiple applications at the same time. And okay, PAPAS of course is fully customizable. Sorry, so you can specify the depth you want in scanning, the number of performance injection, the timeout between pages, and so what we did, we used this tool to test internet site and to see how many of them are actually vulnerable. And now that the research is pretty much finished, we decided to release this tool as a free-to-use service that is reachable at this address. So maybe what I can do now is to show you a bit of the tool, how it works. And while this tool is actually scanning my web application, I can go on with the talk. So let's see if internet works. So this is the page of the tool. So yeah, if you go to submission, actually yes, you have you can submit your own site for being tested. Okay. So your email space. So here just specify one, that means that we only scan the home page of this site. So this service is available for everybody to use. So we received from 20 to 50 usually submission per week of web developer that they test their own site. And so it seems that is working pretty fine. So sleep time is 0, means, okay, we don't want any time between the page being tested. But somebody maybe may want to add some timeout to not have their production system be tested too rapidly. We enable pscan, vscan. We enable the extensive mode, that is that one where it tests parameter under different names. And we don't want to have any regexp. This regexp is used if you want to exclude some pages from being tested. And if you have PAPAS running on your own machine, what you can do, you can test, for example, the authenticated section of a site. So suppose you have a site for online check-in, you can log in. You can say to the browser to record your username and your password, and then you can say to PAPAS, don't log out. Okay, so for example, exclude all the URL that contain logout.ggi. This way you test the authenticated area of a section of a site. So I think it's okay. Okay, so now we just submit the site for being tested. No, like this. It's okay, no? Yeah. Okay, so what the tool does, it creates for you this token. Okay, this token should be uploaded to the site you want to test. Okay, why I do like that? Because I want to make sure that the guy that submits the site for being tested is actually the author of the site. Okay, otherwise everybody can use this system to test site of other people. So what you have to do, you have just to create a file called papas.txt, where you just you put this hash. When you log in on your site. Sorry. So now if I go to this address, before uploading the token, yeah, the tool tells me that the token is not there. Now what I do, I upload the token. Okay. Then I check again. Okay, so now the system has validated the token, and the site has been put in the queue for being scanned. Now, depending from the load we have, it will take from some second up to a couple of minutes, and we will receive an email when the scan is finished. So in the meantime, I can go on with the talk, and I can show you actually the result we had from our experiment. So let me talk about ethical consideration, because our idea was to understand how much this HPP problem was prevalent over internet. So we scan a lot of internet sites. So I want to say that we provide, when we scan the application, we only provide this full equal bar, the nonce, okay, that is not malicious. We limited the scan to 15 minutes. And then we immediately informed, when possible, the different security engineer of the affected application. And in the case where we found problem, we always had thankful feedback. So we used purpose to scan about 5,000 sites that we collect from the first 500 Alexa categories that are like this. So we test more than 1,000 financial sites, about 200 health sites, news, organization, and so on. So the first part has been, yes, to test this web application. And we did it in 13 days, okay? And in total we test about 5,016 different sites, and that means about 150,000 unique pages. So as I was telling you before, to maximize the speed, we used different 5 instances of a browser at the same time, and we decided to crawl up to a distance of 3 from the home page. Okay, so we say to the crawler, check the home page, check the links, go into deeper links, go again until you reach a depth of 3. Then we disable pop-up images, any plugin for active content technologies, such as Flash. So you can actually, a limitation of a tool now is that it does not support the links that are embedded in Flash content. So there are some sites that are computing Flash, and you actually interact with a Flash to go around the site. We don't have a support for this at the moment, so that's why we disable Flash content. So here are the results. So the first things we check is whatever the web application was giving a database error when the same parameter is repeated twice. And here it came out that about 5% of the application actually came out with an error. This is really a lot. And this means that who designed the application was not actually aware of the fact that a user can submit the same parameter twice. So suppose you have an application, for example, in Python, where if a parameter is duplicated, you follow up in having a list. So in that case, if this parameter is used to make a query to the database, if you have a list, you have an error. Okay? So you follow up in having something like this. This is on the government site, on the site of nasa.gov. So, if here you have a parameter called ID, I'll show you here, that is equal 23. Actually, if you duplicate and you inject ID 24, probably you follow up in having a list and you have an error. Actually, this problem is not of NASA itself, but of this Code Fusion application that is used to render video. So this is the multimedia section of a site. Then about this, here we check how many applications have access, are actually handling the parameter in inconsistent mode. That means that some pages of the application accept the first parameter, some pages accept the second parameter. So this is something maybe strange, because you can think, okay, if an application is designed in PHP, should always be accepting the first parameter. Actually, this is not the case. The applications are complex, and different pages use different technologies. So there is nothing bad with this if a developer is aware of the fact that somebody can actually exploit this problem to run HPP attacks. This is actually the case because we discovered that out of 1,500 websites we test, about 30% of them contain at least a single page that is vulnerable to HPP parameter injection. This is really a lot. What is important to say here is that when I say vulnerable, it actually doesn't mean that it's exploitable. Vulnerable means that somebody can actually inject a parameter into the application. But then the question is the parameter precedence consistent? So can we actually overwrite existing parameter and carry out attack? So to answer this question, we can do it like that. So if injection is on the link, suppose you have a URL that is actually used to read an email, okay, where you have two parameters, the ID of the mail you want to read. Where is it? Yeah. Whoa. Here, you have a mail ID, 10, and action is read. Suppose you have an injection here, and the attacker is able to inject a new action that is delayed. So if this injection follow up in the middle of the link, so you can always override a parameter. So you can decide if a precedence is on the first parameter, so you can actually if you inject it here, you will override the action read, so you can actually delete mail. Instead, if a precedence is on the second parameter, you can write mail ID equal 20, so you can actually override the mail parameter. So when the injection is in the middle of the link, there is always overriding. Instead, if an injection is either at the beginning or at the end, you should check the precedence given by the application. And this one can be done automatically using the pscan component I was showing before. So this pscan scanner test for the precedence and can tell you whether an application is just vulnerable or exploitable. And instead, for forms, it's a bit more complex, because if injection is on the action field of form, you have an injection. Instead, if it's in the input value, here there can be an injection. There can be a two-step attack or a server-side attack, in a sense that browser automatically encode the value that are submitted in the field. So just to sum up, out of these 15,000 applications, we came up with 700 of them are actually exploitable. That is 30%. And in this graph, I cannot go to the next page. Ooh la la. What's happened? Where we are? Okay, now I see. So do you see here? Here you have different bars. So you have a different category, no? So the first one is the financial side, then we have games, then you have government side, and so on. So in red, it tells you the percentage of sites that are exploitable, and in blue, how many are vulnerable. So as you can see, the value are pretty high. So in general, is a common problem. It's a big common problem to different sites. And what is interesting is sites that are more sensitive, or that should care more about security, such as a financial site, a government one, are actually equally or even more affected by the problem. That's why we found a problem in a lot of famous sites, such as PayPal, Google, Symantec, Microsoft, Facebook, Flick, Fox Video, VMware, and so on. So I personally notified the security officer of this site, and in most of the cases, they were thankful for the problem. So for Facebook, there was this share component I was telling you before. So the fact was Facebook was the API used by Facebook for sharing information over internet was not checking whatever the parameter submitted was once or twice. Then we had a lot of several shopping cart application where it was possible to change the price of an item, so possibly to buy a price to buy a product at a lower price. Then we had banks where there was vulnerability, and then Google as well. So this is, for example, the World Health Organization. You don't see it, but if this is on the home page, so if you can inject on the home page and you follow up to have all the links here on the left that have been injected. Then you have your secured home banking. So this is the US bank, where you can actually apply for this US bank secured Visa credit card. Here there was an injection, so if I send this URL to you, and then you click on it, you have this page, but then when you apply for having this credit card, actually you received another one. You received the young adult Visa, so the young version of a credit card. Then you have, this is PayPal. So the problem here in PayPal was in the authenticated area of the site where it was possible to raise the limit of a credit card registered on PayPal. And finally in Google. So it was possible to inject in the language field that is HL, where you specify the language of your, when you do search engine, you can actually inject there a parameter that then is used to compromise the answer when you actually look up. So what's next? What we're doing now is to run into white box approach. So the limit of black box testing is that it's cool because you can test applications that are not yours because you don't have a code, but it's very difficult to test for server-side attack because since you don't have the server-side code, you don't know what's going on there. So the best way now is to go for the white box solution. That means doing static code analysis. This is a complex task. There are different solutions and technology that claim doing it. So one, for example, is a Pixie. And the other one is RIPS. That is both of these one are static code analyzer for PHP code. So the problem here are basically three. One, it's the parsing, an efficient way to parse code, okay, especially when you have, for example, multiple array. The second one is the object-oriented support. Okay, so none of existing technology has object-oriented support. And the other one is when you have a sanitization routine that have some are custom. So the developer wrote his own custom sanitization routine. So we're working on this. If you feel being interested in this field, just drop me an email and we can see what we can do. So to conclude, I will tell you about the prevention. So you are a web developer. Yes? You have a question? You want to do it now, before, after? Okay, so about the prevention. The first, prevention, it's pretty straightforward. It's actually doing input validation. So since this is a web injection vulnerability, the same way you protect your application against SQL injection, cross-scripting here is the same. You should check that you actually, in the value of the parameter that are submitted to application, you don't have a query string delimiter and any of the encoded version of this query string delimiter. The second prevention is to use safe methods, so to end of a parameter precedence. For example, in Python, instead of using the get value parameter that return you a list in case you have multiple parameters with the same name, you can use the get first. Using the get first, you always get a single parameter, even if somebody submit to you the two parameters with the same name. Second one is to use a channel validation. So to check that if the data should come from the get, they're actually arriving from a get and not from the post. And finally, to raise awareness. This is why we are here. So we want to make sure that web developer know that the client can provide the same parameter twice or even more. So this concludes basically my talk, and thanks for your attention, and I hope you don't get sleep completely. Go ahead with question, yes? Yeah, you mean, yeah, what you can do, you can, for example, if you have a parameter in the cookie of a vulnerable application, you can inject your parameter, for example, in a get, in a post, and this parameter then is used by, when it's read server side, you overwrite the value of a cookie, and so that's the idea. So actually, you are attacking you don't have cross. Yeah, we can, yeah. What's happened? Yeah, good question. I don't know. In ASP, I know that if you submit the same parameter twice in the get, yeah, you have concatenated with comma. This is, I don't know. Actually, what it would be interesting to see is how the precedence is handled using a cookie, because our tool just works with get post. So with cookie, I don't know how the precedence is handled. Yes?
So have you considered using a pound sign to push later parameters into the hash so that you always override them when you come before them?
I didn't get your question.
So what you're doing right now is you're duplicating parameters.
Yeah.
Because you can actually include a query string delimiter.
Yeah.
If you could include a query string delimiter, you could also include a pound sign, which would mean everything that occurred after that in the query string would be part of the hash and would be ignored. So that means if you occurred before a parameter, you could overwrite it always.
Yeah.
Have you looked into that?
No, we haven't looked at that. Yeah, but it can be, maybe we can get in touch later and yeah.
Okay.
Sure. Do you have more questions, guys?